This is Dr. Carroll, and this video is about the objects class in the context of inheritance. So in Java, all classes that don't explicitly have an extend, so they don't explicitly inherit from another class, are going to implicitly inherit from the class entitled objects. So this is a pretty important class, so let's talk about what that means. So let me give an example here. So the string class inherits directly from object, okay? And we'll see some of the properties of that as we spell out some of the methods of the object class. So if we had a simple bank account class with, then if we didn't say extends anything, that it's implied extends object, and so we'd represent that as a UML diagram here, that it extends object and inherits from it. And so simple bank account could have other accounts that inherit from it, like a checking account and a savings account. So we would say simple bank account implicitly inherits from object, but savings account inherits from simple bank account, and it inherits from object, and so it inherits it from the simple bank account, and so, or through it is a different way to say that, okay? And so what this does is this allows Java to make some assumptions about all classes. Namely, we know that all classes are going to have the methods available that are described in the object class. So let's look at some documentation here, the current documentation. Here is the object class. It's the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. Pretty important class. Okay, so it has a constructor, has all these methods. I want to focus in on equals and toString. Okay, so toString and equals. We've already seen equals in the context of a string, and so let's talk about each of these in turn. Okay, so let's first talk about toString. So what toString does is it returns a string representation of a class. And so as defined in objects class, what it does is it returns getClass.getName concatenated with ant, concatenated with integer, 2-hex string, hash code. Any questions? Yeah, that's kind of crazy, and it's not usually very helpful. But this is the default of what you get if it's not overridden. Java will implicitly add a call to toString if one is not given, if we're treating it as a string or calling it in a string context. For example, if we're using it with a print line or print method, or we're using in string concatenation, then it's going to go ahead and assume that we meant to add in a call to toString and do that for us. And so since this is so common to be done, this method is commonly overridden to return something much more informative than the get name and a hash code of where it is stored in memory. So let's see an example here. So if we created a savings account and called it, and then we used the reference to that object in a print line statement, it will end up calling, if we haven't overridden toString in savings account, it will end up calling objects toString. And this is the same as calling it with print line, but then saying .toString. These are equivalent. These calling savings are calling savings lines of like savings account at blah blah blah, blah, which is an indication of where it is in memory. Okay, well let's do a little demo here, building off of the shape circle and shape driver class that were shown in other inheritance videos. So if we go to shape driver, and we have, as we have here, but now we want to demo toString. So let's change this from calling print. Let's do something like system.out.println and then call circle here. Okay, and let's implicitly call the toString method on that circle class. Let me save it. Now let me compile it. Java C shape driver. Woohoo! It compiles. So now let's run it. Shape driver. Huh. Look at what it displayed. It displayed the class name and then some indication of where it's stored in memory. It turns out if we run it again, it actually happens to be placing it the same place in memory. That's not always true. If we did some other things, it would mix that up. So that's not very helpful. That's not a great toString. And notice also, if we cut that out, we just give it the reference to an object, which is what is typically done. It does compile, and it gives us exactly the same thing. Okay, so that's because toString is not overridden in the shape class. So let's go, or the circle class. So let's go in here and let's add in a toString method. Now toString is public. It returns a string object and it takes no arguments. Okay, and so then we're returning a string argument. So we return shape, and in this case we could do string concatenation here, and now that will return our string, and we could have made a temporary string and then returned that. That would have worked as well. And so let's see if this compiles now. Woohoo! It compiles. Now what's going to happen when it runs? Remember, let's look at shape driver again. Shape driver, we're calling println on circle. So it did compile. Now when it runs, we call toString on it. It's getting the toString from the parent class because we have not overridden it in the base class. Okay, so let's come in here. This is toString here. Let's go to the circle object here, and we're gonna override it here. And oh, I forgot. This is overriding as well. So if we go back to circle, we're saying it overrides an overridden method, because really what we're doing is we're overriding shapes toString here. And so we could call, so we could do area here, and then we could add in another line, and we could do what we're doing here. Yes, we're repeating it, but we're now doing it the more Java way of doing this. And let's see if this compiles. Woohoo! It compiles, and now notice we are displaying shape and then area and radius here. And so, and just for completeness, we could have reused code and said, hey, really, we just want the toString of shape. We can't use shape here because if we did shape.toString, that's trying to call a static method. That's different. We want to call the toString method that operates on the parent class. Return that and then concatenate that with even more that we have here. Okay, and now this should work. Woohoo! Compiles, and there we go. we have the exact same thing. So that was toString. Now let's look at equals. So here we have equals, and equals, notice, takes an argument. And so the argument is of type object. And what it does is it returns true if the parameter, obj, object is how we would pronounce it, if that parameter and the object that called equals are at the same location. That's what the object method does. And so this is commonly overridden by comparing fields. So for example, the string class that we're familiar with, it overrides equals and returns true if the two character sequences are the same in both the parameter object and the object that equals was called on. So for the circle class, we could return true if the radius of the object and this are the same. If we wanted to redefine it to say, I want to say that one is equal to another. That's it for this video. I hope you enjoyed it.